And again, the problem, one of the reasons we haven't cured cancer is what?
Because it uses our own tissue, so wouldn't it be hard to kill?
It is, but what's one of the other reasons we haven't cured cancer? This is the problem with people like that. I guess there's a thing, was it Israel, some lab in Israel said they
They're
cured
close.
cancer?
They're close to curing cancer.
Close to curing cancer. The problem, man, is cancer, the term that encompasses what?
Oh.
200 different diseases. He's not gonna cure cancer, you're gonna cure cancers. Nobody's gonna get out there and all of a sudden cure all of them. That occur at different ages with different rates of growth, differentiation, detection, evasiveness, capacities to spread. There's a bunch of them. Cancer is just a general term for what? Uncontrolled cell growth, right? There's no single one out there. Otherwise, we'd already cured it. Okay. And adding the suffix oma to the parenchymal tissue type from which it is grown. So what? Adenomas, things like that. Sarcomas. Going to tell you what? The tissue and the normal part is telling you it's what?
Cancer.
Cancer. A lot of people go to Metallica last night. A lot of people not here. If you went, was it good?
Yeah, that's great.
Good. And you came to class too, that's even better.
And I'm wearing my shirt.
And you paid your shirt. I can't believe you tickets.
You didn't go.
$300 for some of the tickets.
And they all sold out.
No thanks.
It sold out like 10 seconds, didn't it?
No,
All right.
it's Fleetwood Mac.
All cancer is genetic and results from damaged DNA or RNA.
It is genetic.
It's not genetic in the sense that it's inherited.
Oh, then
Remember we
what?
talked about that before, we were talking about that yesterday? Wednesday, it's not inherited, it's not heritable. You can get inherited traits that predispose you to cancers. Those BRCA1 and BRCA2 mutations, those are heritable, those aren't cancer, those predispose you to cancer.
So it's not inherited, but it's in your genes. That's why it's called genetic.
Right.
Oh,
There's a damage to your
yeah.
DNA. Something affects your DNA or your RNA. And now they're also looking at epigenetic factors. Anybody know what epigenetics is?
Something to do with is it like the alleles?
No, it's not much alleles. So when you all went through transcription and translation, right? Transcription, you have to come in and you have to open up the DNA, right? And copy that gene. Well, we don't go to a whole bunch of the other stuff in these classes, especially 1306, that you have to do to get it to open. There's things called methylation and acetylation. So if your DNA is highly methylated, it's sort of like putting a lock on it. You can't get in there. Okay?
And when you can't methylate, say like B12, vitamin B12.
Okay, but that's different. That's a vitamin. That's.
But that means you can't detox it, right? Or you can't break it down?
Methylation.
Because that's what they said I had. Just asked you.
Let me look that up and see what it is with that. Because a lot of that may be with either
Like,
metabolizing it or you're methylating it. So you
it just says I'm predisposed to a non-methylation or like methylizing B12.
But that may have something to do further down the pathway where B12 is involved also. So I have to look on that. But this is just talking about DNA when you methylate. The point is, you can add epigenetics to that, okay? That's one thing they come out now where they think there may be some of these epigenetic things. That things are being, that tumor suppressor genes are being highly methylated so they're not turned on, or other ones are being unmethylated and acylated so you're turning on oncogenes, okay?
Okay, and let me ask a ridiculous question. What does methylated mean?
You add a methyl group to it.
Oh, okay.
And it sounds trivial.
Yeah.
But it's not. That's how you turn a lot of things on and off. You methylate
Oh.
Remember phosphorylation?
Yes.
Kind of along those same lines.
Okay, got it.
A mutation is what?
Change?
Change in what? I got
Gene.
an extra I.
Gene and a sequence.
Changing your genetic sequence is used to. I'm having a bad day today.
It's Friday.
It's Friday, it's okay.
God, this is good. It's used to define a process causing permanent change to the DNA sequence. That is a mutation. Are mutations all bad?
No.
No.
No. Are most of them?
Yeah.
Yes.
Yes. Some of them are, don't care. Some are what they call silent mutations that don't matter. Some of them are actually what?
Beneficial?
Beneficial. That's what I'm good. Some of them are actually good. In general, they're not. I'm like,
Like a mutation meaning like people that are Like they're resistant to AIDS and stuff. That's a mutation that we're talking about back in micro, or is that what you
They're
mean?
the people that are called long-term non-progressors, or I think they call them elite controllers now, have it. Now, they've inherited that mutation.
Oh, okay, so
they
this is
didn't
not
get
the
that
same.
mutation.
What would be an example of this kind of mutation then?
Anything that changes,
Like a good one.
I walk outside right
Good
now
one.
in the sunlight and I got a DNA yeah, it is Friday. A thymine dimer in my DNA, that has changed my DNA, right? That's a mutation.
It's a king.
Whether
Okay.
it's gonna do anything, it doesn't, that depends.
Oh, okay.
Somatic and germline. The germline mutations are inherited mutations of the egg and sperm. Those are bad, okay? If you get a mutation right now, right, are you gonna pass it on to your children probably?
No.
Mostly you're not going to, right, unless it's a germline mutation, that's the dangerous one. Those are heritable mutations.
Oh.
So dangerous inherited mutations?
Right. Or germline, they're gonna be in the egg and the sperm. Somatic mutations occur after conception and are generally not inherited. If I go and get exposed to benzene right now and I get a bunch of mutations in my liver and I have children, am I gonna pass those mutations on?
No.
But if you do get them, if you do damage the egg and the sperm, then you can what? Pass that
Pass it on.
mutation on.
So what can affect it after, like the egg and the sperm? Maybe like radiation, and that like can.
Oh, chemicals, all kinds of things you can get. That's why sperm is one of the protective. You remember the blood-brain barrier?
Mm-hmm.
Those protected sites. You have the blood-brain barrier. You also have the blood-testis barrier. Because developing sperm are very sensitive to chemical damage, and you don't want these germline mutations. It's just kind of weird. Okay,
I didn't know that.
so. Trying to think how to do this later on. We'll just leave it out.
Okay.
Yeah, never mind. We'll just leave it at that.
Okay.
If it's a germline mutation, if you get damaged, because they're talking about mutations in you right now, not something you've inherited down the line somewhere else. If you get a somatic mutation, you are not gonna pass that on, that is not heritable to your offspring.
Yeah.
Germline mutations will be.
So if a pregnant lady got next to like someone who was taking x-rays and she wasn't wearing a vest, would that be germline?
No,
No?
because she's already pregnant.
Got it.
So if you didn't damage the fetus, it wouldn't be germline mutation at that point, it would be what?
Somatic.
A somatic mutation in the fetus already. That's a tricky one.
Oh, because of the conception word.
If you were to walk by a bunch of x-rays and your egg developed mutation,
Then you would,
that would be a
germline.
germline mutation, right? Because it's in the egg, that would potentially pass on. One of the protections to prevent germline mutations from spreading is what?
Not having any more kids.
Well, that's one. But inside, a lot of those mutations are gonna be what they call embryologically lethal, too.
Oh.
If you have enough damage to the egg or the sperm, it's just gonna.
Miscarriage.
How many pregnancies, how many conception pregnancies actually go to full term?
Very few.
About 25%, that's about it.
Yeah.
About 50% of them, the woman doesn't even know she's pregnant.
Mm-hmm.
So you have all these mutations and stuff, and there's something goes wrong, and they just drop off.
So they don't even know that they, like,
Nope, a lot of times it'll happen right away, there'll be so much damage, criminal damage and stuff, that it becomes what they call embryologically lethal, so they don't even know that.
weird.
Mm-hmm.
And it just is like a period or what?
Yeah.
And
Yeah, or miss like if
drivers
you're like a week or two late, sometimes you're.
are not people working for Uber. Drivers are cancer-causing mutations in genes known to cause tumor-suppressing roles, excellent targets for cancer therapy.
I noticed there's a lot of vocabulary in this one. Is that going to be conducive to like the test? Like, should we be like?
This one will have my more vocabulary in it and stuff.
Okay.
This is terminology you guys really need to be
Yeah.
familiar with.
That's what I thought the first one was gonna be, but.
So a driver gene, if you get a cancer, something like P53, right, a tumor suppressor gene, what happens? So cancer-causing mutation genes known to cause tumor suppressing role. Excellent targets for cancer therapy.
So they're good then.
Right, so these are things you can maybe fix down the line, that's kind of the point they're talking about.
Oh.
Like, does that mean that if you have that mutation, then when you get therapy, for cancer, it'll work.
It should work, and there's different ways, you can look at it repairing P53, so just know what a driver is. It's a cancer-causing mutation in genes known to cause tumor suppression. Tumor suppressor genes, you're mutating those. So
And that's the
they're not working.
P53 we're just talking?
P53 is one of the big ones, although they just found a new role for P53. All right, passengers are mutations with no known cancer-causing impact and only accompany the drivers. So this will be a mutation in the DNA somewhere, but is it gonna lead to cancer?
No.
No.
So it's like kind of what's the other one where it's
Could be a silent mutation, it could be.
no, like what's the other one, the bacteria that doesn't affect you?
Oh, like a commensal kind of.
Yeah.
Yeah, sort of, yeah. So you get a mutation in some gene somewhere. If the mutation's in some gene somewhere that doesn't have anything to do with promoting growth or anything like that, or suppressing growth or anything like that, it's probably just gonna make some messed up protein or something, right? It's not gonna have that big of an effect. That's what they're talking about.
Oh.
Drivers or mutations in genes that could eventually lead to cancer, for whatever reason. Passengers are gonna be mutations that they're not gonna be cancer causing. Okay, sickle cell anemia is due to a mutation, right?
Mm-hmm.
Does sickle cell anemia cause cancer?
No.
No.
No, so there you go right there.
Oh.
All right.
So that would be an example of passenger then, right?
It would be, but that one's inherited now, so that happened a long time ago. So the very first person that had that mutation, that would have been a passenger.
Oh, but
It didn't
now
cause
it's
cancer.
not.
So
Okay.
now it's just an inherited disease right now.
Or no?
Got it.
And remember, they're talking about you getting mutations now.
So, okay, drivers isn't good then. It's bad, but
but
we
it
have a
gives
way
it gives
to
you a target,
treat
though.
a target. Okay.
And one of them's a thing called KRAS, we won't go into it, that's one of the ones, that's a cancer promoting mutation, and a bunch of cancers have it, but it's not what they call a druggable target. It's a good target, because if you can get rid of that, you can stop the cancer from progressing. The problem is, it doesn't have a place on it where you can, what we call a non-druggable target, so they can't be able to stop it. It's a good choice, we just can't do it, right? The gene products of an altered DNA sequence changes the cell division of proliferation, apoptosis, vascularization of a tumor, angiogenesis, we'll talk about that, and alternate forms of energy production, we'll talk about this right here, because this is the big one in cancer, right? Most of your cells are going through fermentation or cellular respiration.
Cellular respiration.
Respiration, right? Why?
Yeah.
What's the advantage to that?
More ATP.
Tons more ATP per molecule of sugar, right?
Right.
What we're gonna look at a little bit is cancers a lot of times switch to glycolysis. But what's the downside of that?
What's the downside on their side or
Lots of
our
what?
What's the
side?
downside of going through glycolysis as opposed to cellular?
Not as much ATP.
You
It's,
don't make nearly as much ATP, right? So how do cancer make up for that? They're rapidly dividing. They need tons of what?
ATP.
ATP. So now what do they do?
Hijack.
What happens with cancer?
You look
What
hijacked.
happens? What do they do to grow?
They grow their own blood cells, or?
They start going through angiogenesis and they start starving the rest of your tissue because they're saying, give me, give me, give me. I don't make much ATP, so I need to burn way more glucose to make the ATP I need. So it's one of the downsides.
So they make their own blood supply?
Yeah, it's called, they create more, they promote angiogenesis. So some of the new drugs out there are angiogenesis inhibitors.
Oh.
So here you've got cellular regulation. And it's gonna be looking at what, these concepts related to cancer, affect the types of cancer, their risks, interventions that can both increase and decrease risk. So this is gonna be cellular regulation, because that's what cancer is, right? And that's what cellular regulation is, right?
Mm-hmm.
All right, acute stress activates the immune response. Chronic stress suppresses the immune response. And your immune system should do what to tumors?
It should stop them.
It should catch them and kill them, and it does most of the time. Everybody gets cancer,
Yeah.
right? Usually we catch it.
Oh.
Right? Now, stress and coping, different mechanisms, and immunity. So this one is gonna suppress your immune system, this one should what?
Stop
Increase
it. Yeah, increase it.
Now you look over here at psychological effects, cognitive issues, emotional stress, risk-taking behavior, mood and affect, these can also all affect what? Cellular regulation. Genetic mutations, inflammation, and oxidative stress. If you mess up your detoxifying systems and you make too much oxidative stress, that can be massively cancer promoting, right? And then up here, this is gonna be environmental factors, diet, smoking, work environmental exposure. And don't, I just put that in, I mean, I gave you this, we'll go through the risk factors later on. But all these different ones are gonna cause different types of tumors. How would this cause a tumor? Is this gonna cause lung cancer?
No.
Probably not, right? Is this gonna cause lung cancer?
Yes.
Okay, this is gonna cause something like what?
Pancreatic.
Pancreatic cancer
Hey.
maybe, or maybe even some liver cancer, something that gets massive inflammation, okay?
Oh, inflammation.
Genetic mutations are gonna have to come in there. But here they're talking about genetic mutations, not so much in a cancer, but in something that's what? It's a cause and effect. So that you may not be able to produce catalase and superoxidase mutase in some of the other ones. So now your oxidative stress levels go up and your inflammation levels go up.
And so-
For mood and effect, what kind of cancer examples would that be?
This one, well, they link with the inflammation, you mean?
No.
For the like cognitive issues, emotional states.
Oh, well, all of these things can also start affecting what?
Well, you get your mood, and then, but what is that?
Immunity, they can affect immunity.
Well,
It's
probably-
just showing all the links and cause, potential
Oh,
cause and
okay.
effects in there. I don't know of anyone that is directly related to this one.
Well,
right
risk
here.
Well,
taking
they have-
behavior would be like,
drug use.
Risky behavior would be, yeah.
yeah.
No,
How
but
risky behavior do it? Give me
like
one right now. risky
drug
behavior.
use,
Drug
No,
use,
but-
which can lead to what?
needle sharing,
Which would lead to what?
AIDS.
HIV.
Or HIV doesn't
Or
cause
Hep.
cancer. Hep C, they'll have BD, right?
And what about like HPV and stuff?
HPV would be other potential risky behavior.
But I've always heard that like if you're always angry and you're unforgiving, like you can get sick.
It can cause a certain type of chronic stress, and chronic stress does what your immune system.
Lowers. Oh.
That's why yogis are all healthy.
I'm sick all the time. Types of tumor, these are gonna be clinically important to you. An adenoma is a benign tumor of glandular tissue, because it's oma, right?
Oh my.
Adenocarcinoma is gonna be what?
Malignant.
A malignant tumor of the glandular tissue. These are the real common ones, are adenoma, adenocarcinomas. Carcinoma is gonna be a malignant tumor of epithelial cells. So, if you give me an example of carcinoma,
Like are those the spots on the skin?
okay, which one?
The brown ones?
Is it a carcinoma, is it a cancer?
Yeah. Yes.
It's when it doesn't have an undefined border.
Okay, what's that called?
It's a cancer. Well,
Well, I
it
know, I
could.
thought I asked you the name.
It's skin cancer. It's skin cancer.
Okay, what's that called?
Melanoma.
Oh.
I couldn't remember.
Like, what do you mean?
What's the name of it?
What are you asking me?
Osteoma is gonna be benign tumor, what?
Bone.
Bone. Sarcoma or malignant tumors of the
Skin?
mesenchymal.
What's that part?
Muscles, things like that, yeah.
Muscles. Aren't those very rare then?
Yes.
Sarcoma?
Because
Because muscle cells.
they don't regrow as quickly,
The
right?
muscle cells normally aren't dividing, are they?
Yeah.
So usually the ones that are most susceptible, are the ones that divide the most.
Yeah.
So it's rare?
Yeah.
Yeah, sarcomas, now they happen, don't get me wrong. Some that I just saw right now, they just came down with an incredibly rare sarcoma, I think, of the nose.
Ooh.
Some of the muscle or tissue inside the nose.
Does it grow?
I don't know, they just said it's super rare. I'm like, okay, I believe it, I never heard of it, it's pretty rare. Papillomas are benign, microscopic or macroscopic, finger-like projections growing on the surface. So what's an example of that?
I don't know.
I was gonna ask for a picture.
Hmm?
I was just gonna ask if you had a picture.
Trying to think of one,
Benign
what's the one that,
Are papillomas just warts? Like,
yeah, mhm,
Baby
Oh.
warts?
yeah.
Oh.
Or I'm trying to think of another one, yeah. I mean, it's called human what? Papillomavirus, right?
Oh.
Like I
Duh.
said, the wart itself isn't cancerous.
No.
It's a benign tumor. It's the damage that chronic infection with that particular virus can then lead to cancer.
Yeah.
so that's why HPV can lead to cervical cancer?
Yeah.
Yeah. But a lot of people get there's only like 3 or 4, maybe 5 of the papillomaviruses they think are carcinogenic.
Cancerous.
Or oncolytic, or oncogenic, I mean. The other like 27, is called papillomas, benign virus. But they can't.
Jeez, there's so many.
Alright, so I just threw some of these in here, Epithelial is gonna be a papilloma surface, squamous cell carcinoma, glandular connective tissues here, so this is out of your book. Muscles are gonna be what? Rhabdomyeloma, that's not a good one actually. Nervous tissues, and then hemolytic ones, we'll look at some of those. Don't go and memorize all those guys on there. All right, characteristics, we'll go back to the characteristics of benign tumors. So back here, they are slow, progressive rate of growth that may come to a standstill or regress even. Sometimes they stop growing, sometimes they'll actually even go down, okay? An expansive manner of growth, which just means what?
They just keep
They
spreading?
just keep getting bigger, right? Inability to metastasize to distant sites, they don't break off, they don't go through metastasis, they stay put. They stay in their tissue of origin. And they're composed of well-differentiated cells that resemble cells of the tissue of origin.
Interesting.
So the one I always like to look at are meningiomas. What is that one?
Oh,
Cancer
What's
of
a
the meninges.
meningioma?
Cancer of the meninges.
Okay, where are your meninges?
Your brain.
In your brain, so it's actually a benign tumor of the brain, the meninges. It starts to grow inward. And the problem with the meningioma
Does it can cause swelling, no?
is that you only have so much room in your
Brain.
brain bucket, right?
Yeah.
So that's why it can cause problems. I'll show you guys a picture of a meningioma. I know I have one. All right.
They remove them, right?
Depends. Sometimes they quit growing. A lot of times meningiomas quit growing. They just get calcified around the outside. They just stay there.
Oh, okay. Like you can live with it.
If you ever really want to do brain surgery, you don't have to.
No.
Yeah. Cracking his head open, not usually a good thing. All right. Characteristics of malignant
Yeah,
tend to grow rapidly and spread wildly. Have a potential to kill regardless of the original location. Jeez. Tend to compress blood vessels and outgrow their blood supply, causing ischemia and tissue necrosis. Not only do they compress it, they also start doing what?
stealing
What are they
their blood
doing?
supply.
They're switching to glycolysis, so they need to do what?
Steal their
What are they sucking away from the rest of the healthy tissue?
their ATP, their blood supply,
Not their
their,
ATP. ATP is made aside.
oh, yeah, because they're,
Oxygen?
Their nutrients and oxygen, so they can actually cause ischemia just by doing that. Liberate in, okay, rob normal, right here it is. Rob normal tissues, I thought I had it here, of nutrients. And liberate enzymes and toxins that destroy tumor tissue as well as normal tissue. So they can set up a very chronic inflammatory environment around it that can cause damage to it, right? But the big one is what? What is the big problem with malignant cancers?
they spread.
What do most people die of?
The spread.
The metastasis, right? They go somewhere else, they start spreading and growing, and start damaging the tissue. Okay, which of the following does not apply to benign tumor cells?
C
Yeah, see?
Yeah.
and D?
Huh?
No, it's just.
Just C?
Yeah, just expansive, no, these are expansive, the benign ones.
No,
are
D, I
expansive.
think.
Oh, D?
No.
Oh, no, because they're well different. Oh,
Yeah,
well.
well different.
Yeah,
Okay, never mind. Oh, no, because they're still kind of like the,
yeah, they still look like the cells are one, okay, so. Okay, so what's gonna differentiate the two if they're gonna do a biopsy and look in there and see what the difference is gonna be what? Cell characteristics. If it's benign, it's gonna look like what?
encapsulated, like it's going to
No,
stay.
this is
It's
cell,
going to
you're
say
at the cellular level now.
the same tissue as where it's from.
It's gonna look the same, it's gonna be differentiated, it's still gonna look, if it's a liver cell, it's still gonna look like a
Liver cell.
Okay? Manner of growth. Is it just growing and getting bigger, or is it spreading into other tissues, moving like that?
Yeah.
Rate of growth. Benign ones tend to grow very slow. Tendency to cause tissue damage, no. Capacity to cause death.
A benign one can still cause
In general, a
death.
benign tumor won't cause death on its own, it can cause issues. Meningioma is too big in the head, it could kill you, right? If you have one inside of your peritoneal cavity, it cuts off the blood in your liver, compresses your hepatic artery, what's gonna happen?
It'll kill you.
Vascular endothelial growth factor, VGF1 and 2, what do these do?
Vascular
Good, they're the angiogenesis ones. Exactly.
angiogenesis ones.
And this is where two of the drugs now are they target VEGF. All right, But benign neoplasms are growths that are not cancer, typically develop slowly, are encased by connective tissue capsule, and they usually have adenoma at the end of them instead of carcinoma, right? Usually non-threatening to the host, but when do we say? Because I love putting these in there. They can cause, so do they directly damage you or do they indirectly damage you?
Indirectly.
They indirectly damage you by the growth being too big. So non-threatening unless they start doing what? Pushing in on structures inside of there, pushing in on nerve roots. What if you had one in your spinal cord? What if it started growing inside the connective tissue there, what would happen? What could happen?
Crowd.
Could be paralysis, they got bad enough, right, so that could cause problems. Did the tumor cause it directly?
No.
No. How about blindness in the brain? But if you had a meningioma somewhere that was going down back down here, it starts to go up.
Right.
Solid tumors, I'm gonna go through these. A solid tumor, people have issues with it tonight, is a malignant tissue originating from epithelial tissue and ends in carcinoma. These are gonna be solid tumors, liver tumors, pancreatic tumors, lung tumors, what else? Gallbladder tumors, right? They're all solid. Malignant tissue originating from the parenchymal tissue into the suffix sarcoma. These can metastasize. They can break off and go places. These are solid tumors.
All those.
All these, yeah, all these
Okay.
are solid. Hemolytic cancers are blood cancers. Are they solid?
No.
No. Do they metastasize?
Wait, which ones?
Do they actually metastasize?
Yes?
They do?
No.
Like, they don't break down, right?
No. They just, blood, they're just cells that are going out floating around. They don't actually metastasize.
Oh.
Okay?
Do they just create more?
They're just making more cancer cells because the stem cells are making more blood cancers. It's not a solid tumor, so it's not gonna metastasize per se. So hemopoietic or lymphoid tissue neoplasms are called leukemias or lymphomas. What's the difference?
What's the
One's in the
question again?
lymph, one's in the blood.
Lymph nodes and then the white blood cells.
Nope.
Ah.
They're all white blood cells, right? There are actually some red ones, but for hemolytic cancer, we use them. If you have leukemia.
Where they originate, maybe.
If the tumor starts in the bone marrow and stays in the bone marrow,
Leukemia.
that's where it is, that's a leukemia. If it starts out of the lymphoid tissue, if it's a B or T cell cancer, or one of the other white cells, it becomes cancerous once it's gotten outside the bone marrow, that's a lymphoma.
So BT or what cell?
Could be any of them. I mean,
No,
there's-
but you said three. BT and.
But no, don't worry, just,
No.
don't worry about it.
Yeah,
Just
the-
know it's the lymphoids,
it's
once they've gotten out of the bone marrow.
Oh, once they get out.
Yeah,
Okay.
yeah.
So leukemia is in bone marrow,
Right, or more stem cells in the bone marrow, leukemias.
and then I don't know why I thought lymph nodes.
No, well,
Because
you
it's
know, you tend to
lymphoma.
find the lymph nodes, because that's where they tend to hang out, right?
Yeah,
But stay there. But
lymphomas.
Once they've left the bone marrow, they're out in the lymphatic tissue somewhere.
So one's in and the other one's out.
Bone
Yeah,
marrow.
one starts with the stem cells
And
inside, the other
lymphatic
one's
tissue.
once cancer that's happened later on. Okay, so what is everybody coming down with now with the connection with Roundup?
oh, cancer. Yeah.
Which one?
With Roundup, what do you mean?
The glycophos,
Lymphoma?
To kill?
Yeah. There's been two huge settlements on that. I mean, like
Oh, because it gets in the food.
lymphoma?
lymphoma, right? So where is this cancer starting?
The blood.
So the saying is you're being exposed to this chemical, and it's getting into your body, and it's causing this tumor formation in some lymphatic tissue that's already outside of the bone marrow, so it's a lymphoma that's causing. And cancer in situ are localized pre-invasive, so breast ductile carcinomas, those are gonna be what in situ.
Stay in the
If
duct?
you get breast ductal carcinoma in situ, what is that telling you?
It's gonna stay there inside the duct.
Gonna stay there?
For now it is.
For now it is, it's localized into that one particular area, that's what in situ is. So it's gonna be localized, pre-invasive, it hasn't started moving other tissues yet. If you get breast cancer, that's the one you want. But you don't want breast cancer.
It means like it's gonna eventually move, but it's staying there for now.
Well, one of the big ones with this is what's one of the big arguments with this now? I had a relative who just had this done. Actually, we were talking about, what class, oh, it was another class, we were talking about, lymphedema. Right, so once the What's one of some of the controversy with the breast cancer carcinoma in situ right now? Breast ductile.
Are you talking about the implants?
Huh?
The implants that are causing cancer?
Mhm.
Oh.
Some of the controversy with it, what is it?
Breastfeeding?
Well, it's one of the ones kind of like the prostate cancer. Some of these are like, are they ever going to leave? Are they going to stay localized? Do they really become metastatic? So there's some, because they're kind of slow growing, some of these, they don't know. So it's, again, I don't know. But there's some of the new oncologists out there, because we talked about the lymphedema, right? When they take it out, they take out what else?
Your axillary node?
Your axillary lymph nodes and your sentinel nodes around the area there, and then what happens to the lymph draining from your arm? It doesn't have anywhere to go, so you can start getting you can get lymphedema in your arm and everything else. And also, if you lose lymph flow and you lose lymph nodes, draining lymph nodes, what happens immunologically in that arm?
Weekend?
Because immunologically weakened. So she found all this stuff after she got that done. She gets this big list of, oops, by the way, you're gonna have to wear this compression thing on your arm all the time or most of the time.
Wow.
Secondly, try not to get any localized infections in your arm because you've lost those draining lymph nodes. And there's just been some question with this particular type of cancer, does it spread or not? I don't know. That's it. Everybody have to talk to it. I would never ever presume to say anything. I don't know nothing about anything else. It's just one of the controversies out there that they're gonna look at. So I don't know. So what? We went over that. Let's make sure I can clarify these things that I talk about. I don't know, somebody come up with it. All right. The term anaplasia is what? That was from the other test. Anaplasia is used to describe the loss of cell differentiation in cancer tissue. They have undifferentiated.
Oh, they've changed.
So undifferentiated cancer cells are marked by a number of morphological changes, including what? Changes in size, shape, conditions referred to as pleomorphism. When they're doing a pap smear, what are they looking for?
Change cells.
They're looking for different shaped and sized cells. So you're looking at precancers, things like that, because they already start going through this. They're undifferentiated.
So pleomorphism is changed to the cells?
Mm-hmm. Pleomorphism is a change in the morphology.
Morphology of cells.
As an undefined shape. Your cells, each one of your cells should have a defined shape, right? So pleomorphic means they don't have a nice defined shape. All right. Okay, I'm gonna finish up after this, and then I want you guys to come up here and look at this, and then I'll see you all next week. Have a good weekend. When you're done with this, put it in here. So I'll get a really nasty email if I forget today. So, characteristics, what? Which one are we talking about? It is not labeled.
Unrated.
Is the first column gonna be
Benign?
cancer or benign?
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 Benign.
Okay, let's go through the list. Growth, regulated, unregulated.
Benign?
Say right away, that's
Yeah.
gonna be benign, good. So the difference here is differentiation, they're still highly differentiated. Cancers are what?
Low.
Low levels of differentiation. Genetic stability, they're still stable. Cancer cells, some cancer cells probably die off. The problem is if you have one cancer cell die off because it becomes unstable, you've probably got another 20,000 there, right? But they have a high degree of genetic instability, okay? They just don't, genetically, they're all messed up. Growth factor dependence, these are still gonna be, what are growth factors?
It's like your younger cells, like I want to say stem cells, but they're not. It's
There
like
isn't-
hormone
it's
regulated
not-
cells.
So what are growth
Hormone
factors?
regulated?
Huh?
Isn't it in your blood?
Aren't they
Yeah,
hormone
they're-
regulated?
Plasma.
But what do they do?
They're the ones that like make you. Aren't they hormone regulated? They're not.
No.
What are growth hormones?
I know, but
What are
Makes you
growth
tall, like
factors?
makes you grow, makes you hit
What are the
puberty.
growth factors to grow anything? Like if that factor's in there, they won't do.
Right, growth factors are factors that stimulate cells to replicate, to proliferate. Growth factor, epidermal growth factor, VEGF, platelet growth factor, growth factor. All these
That's what I'm saying, I
things
think it's in your
stimulate cells to
plasma.
grow. If you are a benign tumor, you still have to have that signaling. Otherwise, you're not supposed to grow, right? So you stop. The problem with cancers, they become growth factor independent. Prostate cancer normally needs androgen to grow. That's a growth factor for it. signaling molecule. After a while, prostate cancers become antigen independent, they no longer need those growth signals. Cell adhesion is still gonna be what? High, yeah.
I have a question. At what point does that become independent? Like an example you gave.
Which one?
Other prostate cancer. So you said it depends from something, and at some point it becomes independent.
Okay, so usually you've got prostate cancer cells, you have the antigen receptor inside of the cell, right? So what it does is, when antigen binds that receptor, translocation of the nucleus, you get cell division. There's at some point during that cancer, either there's a mutation in the receptor, so it no longer needs antigen to bind to it, to turn on growth signals, or it just doesn't need the growth signaling anymore at all. And it depends on when it depends. But that's why the first line of treatment for prostate cancer is what? Anti-androgens, right? And those work for a while until something happens and they become androgen independent. And I don't know if they all go through it or exactly when or what triggered it. Some of them are always like that. The real aggressive younger ones, when young men get them, those are usually already androgen independent, growth signals. So I'm not sure exactly. Do you mean, is there like a set timeline where they switch? Is that what you're asking?
I just wanted to know what was the, like, what happens that it becomes independent?
Some of them they don't know. I know some of the prostate cancer, I don't think they know. I'll ask the prostate cancer specialist, I know who does work on that. But I think some of they just want the cell somewhere, mutate somewhere. And, okay, put it this way. There's one cancer, just open the gate on this one. One of the prostate cancers, you'll get a mutation in there in what is that mutation? It's 22RB1 cell. So they lose the ligand bind, that mutation gets rid of the ligand binding. So cancers are genetically unstable, right? So they're constantly going through issues. So eventually these cells lose the binding domain on their androgen receptor. Now, without that ligand binding domain, that receptor is always turned on. So that switch right there, that mutation causes them to become antigen independent right there. And I don't know if it's just inherent genetic instability that causes it, and I know it does sometimes, but I don't know if there's something else that can trigger it, but I'll look. Density dependent is what?
Thickness, like
This
the,
is cell-cell interaction, not just adhesion, but also cells. You have contact inhibition or density inhibition. Cells start getting too crowded, they get signals to do what?
stop.
Okay, if you're gonna grow a plate of cells, you look at this in micro, in a tissue culture flask, normal cells are gonna grow until they do what? They fill up that flask and they get contact inhibition and they have signals to stop, because your body's not supposed to keep growing like that. Cancer cells lose that density dependent or that contact inhibition, and they'll just keep growing and growing and growing. So that's another signal they lost. They also lose anchorage dependency. Most cells want to be attached to their tissue in their microenvironment. Cancer cells don't care about that anymore either. That's part of metastasis, right? Cell communication is going to be what? These guys are still working normally. These guys, do they care?
Oh.
No. Antigen expression, this is different. This is where your immune system comes in. In benign tumors, if they don't change really genetically or anything else, they don't start expressing any of these cancer markers. Whereas tumors do. They start changing